Welcome to this video. We are going to solve International Advanced Level Mechanics M1 January 2021. Let's move to the first question. First question is, a small stone is projected vertically upward with a speed of 20 meters per second from a point O which is 5 meters above the horizontal ground. The stone is modeled as a particle moving freely under gravity. Find the speed of the stone at the instant when it is 2 meters above the ground. So let's start with first of all drawing. As the question is saying that it is 5 meters above the horizontal ground. So let's say this is the horizontal ground and it is 5 meters above the horizontal ground. This height is 5 meters. And it's projected from here with the speed of 20 meters per second. So let's take the positive direction upwards. I mean, if any direction will be upward, that will be taken as positive. The particle is projected with the speed of 20 meters per second. The stone is modeled as a particle moving freely under the gravity. So we have to find the speed of the stone at an instant when it is 2 meters above the ground. So what will happen when it is projected from here? It will go up to maximum height and then will come back. So when it will be 2 meters above the ground, we have to find the speed at that instant when it is just 2 meters above the ground. So as we have taken our upward direction positive, so I will use SWAT equation. It's better if you write through SWAT. Now what will be S? As now it is below the position from where it is projected, is 3 meters below that position because we have to find the speed 2 meters above the ground. So I will say S is minus 3 meters. U, the initial velocity with which it is projected upward is 20 meters per second. V, we don't know, we have to find it, so just write it V. A will be gravitational acceleration, which will be minus 9.8 meters per second square in this case, because we have taken the positive direction upward. And time, we don't know the time, so let's say it is t in this case. So we need to find the speed. I can use the equation which don't involve time. So that will be, if I will use v square is equal to u square plus 2as. So let's put all the values in this one. Now v square will be equal to u, which is 20 square plus 2 into a. A is acceleration due to gravity, which is minus 9.8, and s is minus 3. So v square will be equal to, let's calculate them. If I will calculate, it will be 20 square plus 2 into 9.8 minus 9.8 it should be. Into minus 3. So we'll get 458.8. And let's take square root on both sides. We'll get v equal to, now taking the square root of this one, will 21.419. Finally, I can say it's 21.4 meters per second. That will be the speed of the stone. In part B, we have to find the total time between the instant when the stone is projected from O and the instant when it first strikes the ground. So for that, let's make the diagram again. Initially it was 5 meter above the ground, and when it is projected upward and then strike the ground. So in that time, when it is projected upward and then strikes the ground back, we have to find the total time. So I will use Sweat's equation again. Now as we are taking our positive direction upwards, so when the ball will strike the ground, the distance will be 5 meters below the original point. So S will be negative 5 meters. U, the initial velocity is same as it was 20 meter per second. It is directed upwards, so will be positive 20 meter per second. V, V is the final velocity when it hit the ground. So in this case, we have to find it. We don't know, because in the previous part, what we found, that was when it was 2 meter above the ground. And A will be minus 9.8 meter per second square, because gravitational acceleration and our direction, positive direction, is upwards. So acceleration is directed downward. So that is why it will be negative 9.8. And time we have to find when it hit the ground. So if I will use this equation, S is equal to ut plus 1 over 2 at square, that will be suitable, because we don't have the final velocity. Either you can first calculate the final velocity using this formula, v square is equal to u square plus 2as. Using this one, calculate the final velocity, and then you can use this equation, v is equal to u plus at, and then calculate t from this one. Or the other option is use directly this equation, s is equal to ut plus 1 over 2 at square. So from here, what I will do, I will put the known value, then we'll find the unknown value. S is equal to minus 5, u is 20t plus 1 over 2, a is negative 9.8. So negative 9.8 into t square. So that will become negative 5 equal to 20t minus 9.8 divided by 4. So I'll calculate this one, 9.8 divided by 2 first. So it will be 4.9 minus 4.9 t square. Shift them to the other side. So it will become a quadratic equation, which is 4.9 t square plus 20t, sorry, minus 20t. It will be negative 20t, because we are shifting it to the other side. So it will be negative 20 minus 5 equal to 0. This is a quadratic equation where your a is equal to 4.9, your b is equal to minus 20, and your c is equal to minus 5. So you can use the quadratic formula, or I will use the calculator here. You can use the quadratic formula. If you will use the quadratic formula, t will be equal to minus v plus minus square root of b square minus 4ac over 2a. So using this one, I'm using the calculator directly. How I will find? I will go to the mode button, equation, and then the quadratic modes. The value of a is 4.9, value of b is minus 20, and the value of c is minus 5. So using that one, the value of time that we got is 4.31, and the other is a negative value. We have, we are taking the positive time, so we will ignore this value, only we will consider this value, which is 4.317. So t will be 4.3179. And the other value of t also you can write, and then at the end we will ignore that value, which is negative 0.236. Finally, we will consider only this value, because we will not take the negative time. T will be 4.32 seconds. So this is the end of question number 1 of our paper.